Okay, so you have properties of real numbers, so commutative property. The order of the values do not matter. And we can do this with addition or subtraction. So a couple of examples I could use, like 2 plus 3 is equal to 3 plus 2. Multiplication, because I'll ask you for one of those also in your homework. 5 times 4 is equal to 4 times 5. Associative property. The grouping doesn't matter. So that means I can go 5 plus 1 plus 3 is the same thing as 5 plus 1 plus 3. Just move the parentheses around somewhere. Okay. I could do it in multiplication too. Pick your favorite numbers. 2 times 4 times 7 is the same thing as 2 times 4 times 7. Don't use an X for multiplication. Use the dot. I was just talking to Mr. Van Loon, and that is probably our biggest pet peeves. So you make sure that you use the dot instead. Question?
Why did we learn in X?
Simplicity. It made everything
I think
Yeah.
I agree. I think the dot would have been easier back in the day because you eventually have to break yourself of that.
Why didn't you change it?
Huh?
Why didn't you change it?
What, change it to an X or change it to a dot?
And why did you do it that?
Because X is going to be a variable. Yeah. I know, I agree. I think we probably should have started off with the dot to begin with. But more than likely, I think, like, when you look at elementary school students, like, they're not going to draw the dot ever. So then that way you don't know the difference between, like, 2 times 4 and 24. Okay, so identity property stays the same. So that means that, I don't know, pick your favorite number. 2. I got 2 first. 2 plus 0 is equal to 2. Pick another number.
47.
47 times 1 is 47. We'll pick other favorite numbers. Inverse property is using the opposite to cancel the value. So pick a favorite number. 19. 19 plus negative 19 is equal to 0. Another favorite number? 4. 4 times 1 over 4 is equal to 1. If I ever go too fast, please raise your hand and be like, can you just wait a second? I have a tendency of talking very fast. Part of it I think is culturally. The other part is the fact that I always have Starbucks in the morning. So my caffeine has definitely kicked in by the time I see you guys. All right, so multiplying by 0 always equals 0.
Example 0 times 0.
No, you gotta pick a different number. Yes.
Pi.
Pi times 0 is equal to 0. Distributive property, where I thought I was never going to do math ever again the rest of my life. I don't know why I got stuck on distributive property. But I'll never forget that.
I never understood it.
All right, so we multiply a value to an expression inside the parentheses. I don't know why I would draw parentheses. Yeah, you could just do the parentheses symbol. Makes me feel better inside to write out the word parentheses. Especially if this video actually like takes, that'd be great.
Parents this. No, parent
Okay, so 2 times x plus 7 is equal to 2x plus 14. Should be the property. So the next 3, closure is interesting. Closure is one of those things I'm like, man, that's back like in the days when I was getting my degree in math. I used to hate the closure property. But the 3, reflexive, symmetric, and transitive, are very important in geometry. So you will use those terms quite a bit towards the end of this school year and the start of next school year. So we end this year with some geometry and some statistics, and then we go towards geometries because we do geometry to start off with an IM2 next year. So reflexive property is really important. A value always equals itself. Like, that's like the boring property. So like A is equal to A, 16 is equal to 16. I mean, that's obvious, but it's called the reflexive property. We use it in geometry. Yeah, but we use it in geometry when we want to say that one side of a triangle is shared in another triangle, and so we use that side is equal to itself, so that we can prove triangles are equal to each other or congruent to each other. So that's where reflexive comes in. We use it a lot. Symmetric property. If A is equal to B, then B is equal to A. So if X is equal to 3, then 3 is equal to X. Symmetric property.
I only see that if it's like f of x stuff.
Yeah. And we use this too because then we can move like X to either side of the equation, whichever side we feel like, the most comfortable with, and that's why symmetric property is important. Transitive property. If A is equal to B and B is equal to C, then A is equal to C. And it's always that one where you're like, it's like a weird, almost like substitution property. So if 4 plus 3 is equal to 7, and 7 is equal to the square root of 49, then 4 plus 3 is equal to the square root of 49. That's what that one means. Not to get like all crazy, because I threw a square root in there. But that's really what we're looking at. Any questions about any of these properties other than the fact that there's a lot of writing?
No, they're kind of,
Why do you need
these last 3 are pretty much all the same thing.
Yeah.
Why do you need so many ways to answer the same problem?
Because mathematicians need job security.
Although I don't think AI will win teachers because it's hard to get emotion out of those things.
All right, so closure property, what it means is that can I take 2 numbers in a set and do something to it and have it be in the same set of numbers? So like what we did yesterday, right? Can I take 2 real numbers, do something with it, and end up with a real number? Can I take 2 integers, do something with it, and end up with an integer? So it still has to be within the same set of numbers. So, and if it's not, then it's not like closed. So our integer is closed under multiplication. Can I take 2 integers, multiply them together, and get an integer?
Yes.
Is there any case where you take 2 integers, multiply them together, and get like a fraction?
Yes. Yes.
2 integers, multiply together to get a fraction. Because it's 2 whole numbers, right? So I can't ever get a decimal. I can't ever get a fraction. if I'm multiplying. Because if I multiply a fraction, then that's not an integer. So this one is
You never see.
true. Natural numbers are closed under subtraction. So pick two natural numbers and I subtract them. Am I going to get a natural number? You can, but will it always be the case? No, this is false. And the reason why is because I could go like 5 minus 9 and I get -4, and -4 is not a natural number. Okay? Even numbers closed under addition. So if I take two even numbers and I add two even numbers together, will I ever get an odd number? No. Irrational numbers closed under division. No. Because you could divide it by itself. So I could take pi and divide by pi and get 1, which is rational, not irrational. Okay, perfect squares closed under subtraction. Take two perfect squares. Perfect squares are something where I take the number and multiply it by itself. So 4 is a perfect square, 16, 9. Can I subtract two perfect squares and get a perfect square? Sometimes, but not all the time. Because I could take 25 minus 4 and get 21, which is not a perfect square. So this is false. Not too bad. Could have been a lot worse on day 3, right? Questions that you guys have?